Now we want to see how to solve systems of linear equations. While there is a more powerful method for solving systems of linear equations, it requires a knowledge of linear algebra, which you may not have had. So we're going to stick with using the Laplace transform method. And here on a page that might be useful for a notebook are the steps that we'll be doing. And you'll notice that in using the Laplace transform method, we need an initial value problem. So in order to do the Laplace transform method, we need initial values. And so here's our system of two equations and two variables. Let me remind you that the x and the y here are both functions of t. So we're just shortening this to x and y, but we really have x as a function of t and y as a function of t is our two functions that we're trying to solve for. So we'll start by doing the Laplace transform on each equation. So here's the first equation's Laplace transform. On the left-hand side, when we do the Laplace transform of the derivative of x, we get s times the Laplace of x minus x of 0. And of course we're given in the beginning that x of 0 is a -2, so we will replace that. And there's the Laplace transform of the first equation. We'll do the Laplace transform on the next equation the same way. And then we want to write them in what's called standard linear form. That means we need all the Laplace x and Laplace y's on the left and anything else on the right. And so we just simply rearrange terms, put things together. Like here, you've got a Laplace x and another Laplace x, so we'll factor out the Laplace x. Same thing on the other one. So there's our system of equations after we've done the Laplace transform. So now we need to solve the system of equations. Now you can see I've highlighted the variables in blue. Our two variables are Laplace x and Laplace y. Now if we were to solve this by hand, say using the elimination method, it would be quite cumbersome to do. In fact, if we were to solve it by hand, even with the Gauss-Jordan method, that'd probably be even worse than the elimination method. So the best way of dealing with this is to have a Ch35. We can form the augmented matrix and use the Gauss-Jordan method on our Ch35. That takes one command. Now that's after you've entered the matrix, of course. And you'll notice the two solutions are right there, Laplace x and Laplace y. And now we need to reverse the Laplace transform. So we need to do the inverse Laplace of those two things. Well, to do the inverse Laplace, each of those needs to look like something in our table of Laplace transforms. And they don't as of now, so to make them look like something, what we need to do is to expand using our TI calculator. That's real easy to do if you notice in the very beginning when I did the RREF on that matrix, I stored the result in a new matrix which I called N. And then down here, I just did the expand on n 1, 3, which is the Laplace of x. And now we'll look those up in the table. Now we'll do the same thing on the other one. Expand it. And then look these up in the table. So, looking in our table, the inverse Laplace of 1 over s plus 3 would be e to the negative 3t. The inverse Laplace of 1 over s plus 3 squared then would be a t e to the negative 3t. So substituting those, we get this as our solution for x. Now we have the same functions over here on the right, and we've already looked those up, so there is our y. So that's the process of solving. I'll show you one more example. For this example, I have included equations that also contain the independent variable, which we didn't have on the first one. And there's really no difference in the steps as far as what we're doing. So again, we'll do the Laplace transform of the first equation, which means, again, on the right-hand side there, we need to just split that into 3 pieces and do the Laplace transform on each piece. On the left-hand side, the Laplace transform of x prime, we just got through doing that, is s times the Laplace of x minus x of 0. And again, the x of 0 will replace with a 3. And then do the Laplace transform on the second equation. Now, what we need to do is to write those in standard form. So we need to take this equation, get all of the Laplace x's together on one side, like the left side, get all the Laplace y's on the left side. Everything else needs to go to the right side. At the same time, we can go ahead and take out our Laplace table and look up the Laplace of t and put that in here. And then simplify some. And then we'll do the same thing on the other equation. Okay, so let's see what our system looks like now. So solving for Laplace x and Laplace y at this point is no different than what we just did. Now it's going to involve a little bit more typing because we got a lot more stuff here than we did in the first one. However, the TI-89 calculator can handle it just fine. We type this matrix in. You can see what I did earlier. I just typed it in and stored it as M, and then did the RREF on M. Went ahead and stored that in a new matrix called N, and then did the expand on the n 1, 3, which is the Laplace of x. Did the expand on the 2, 3, which is the Laplace of y. And then we need to look each of these up in our table. The 1 over s plus 2, e to the negative 2t. The 1 over s, that's just the 1. The 1 over s squared, that's a t. And that gives us our solution for x. And then the ones that you see over here on the right-hand side are the same things, so they're just going to have different constants on them.